connection, like special connection from the vendor or your client, that has to be created in the catalog. Okay. Uh, there can be inconsistency when there's a minimum tube is less than the tube between the components is less than the minimum tube specified in the settings. This might cause a problem in bolt removal or bolt tightening, right? So minimum tube has to be specified before we do check, data consistency check. Okay, so there is a button for data consistency in the piping tab. I will come to it, but let me discuss what all tolerances you have to give so that some errors can be permissible. For example, offset between two adjacent components. So that adjacent components, the displacement angle between arrive and leave axis. What can be the permissible limit? Maybe it will 0.01 degree or 0.01 mm. That is permissible. Otherwise, it will report lot many errors. The offset distance between arrive and leave axis, angle and distance. Okay. Right. So we are talking about this component. So this component has arrive this side and leave this side. Small figure of is drawn again here. Right. So to show the angle and offset, the ratio of the offset to the projected distance between the arrive and leave. Okay, so this is the ratio, offset ratio to the wire. These values you have to fix it, and you can also specify minimum tube length. What is the minimum tube length? Normally it is 100 mm by default. You can specify minimum tube length by bore also, like from half inch to 1.5 inch. The minimum length can be 100. From 2 inch to 4 inch, it can be 150, and so on. Right? But standard for all bore is 100 until you change it. Okay, so when you check the consistency, the report, there are five categories of error or warnings which are reported. Those are categorized as A, B, C, D, and E. A represent for branching head errors, B represent for branching tail errors, C represents for branch without any components error, D is for components, and there's another category, E is a mixed category, which we'll study in the end. So they have given one example over here. For example, data consistency diagnostics. So here you can see A and B type messages, and also actually this is pipe A, this is pipe B. Both are connected with each other, and this is the flow direction, right? So for this pipe, it has a flange here, and you can see. So this pipe will be a branch also. Here the tail connection type. So its tail is connected to the head of the pipe A. Pipe B tail is connected to the head of the pipe A. So potential errors are recorded here, right? So flow goes from head to tail of pipe B and then enters head of pipe A and goes towards the tail. So at the terminal components are gaskets and flanges. So these are the terminal components. So what will be the connection type for the flange? It is FBD, means flange race face 300 rating. For the gasket, it is GBD, right? So what makes the tail of the pipe A will be the terminal connection for tail of the pipe B will be gasket type because its end component is flange, so it will connect to a gasket type, right? Similarly, for head connection of pipe A, it will be flange type because the last component is gasket. So it will connect to a flange type connection. So this is an ideal connection. This should match, otherwise inconsistency will be reported. So here A230. So it's a A error of branch head, and 230 is a code. So connection type mismatch. Connection type head connection is not same as terminal connection. So in case if it is here, uh, yeah, head is this side. So this is pipe A has its head at this junction, right? So it will be for this. So here it will be FBD. So it expects a connection of GBD at the other end, right? So if this is not matching, 230 will be reported. And similarly for tail side, this pipe has a tail over here. So in this case, the GBD is a tail connection for pipe B. So it expects a FBD at the other end, right? So this will be reported if it is the connection compatibility is not there at the junction. Paired arrive connection type. So the connection type GBD in this GBD FBD example must be listed. So if GBD and FBD are not compatible each other, means it is not registered in catalog. This, by the way, this is registered in master catalog, so not a problem. But if it is a new connection type, and if it is not registered in catalog, it will report bad arrive connection type and leave. There is a E error for component specific leave connection type of the flange not compatible with tail connection. So here, if it is FBD and the tail connection at the end of pipe B is not GBD, then E730 will be reported, right? So these are some example of how diagnostic message can be read. Then example of diagnostic message for head of the branch. See, all these are all A category errors for head of the branch. Somewhere it is head reference points to a non-existing element. If the head reference is deleted, this will come bad head return reference. So head is connected to an element that does not refer back to the branch, means head is connected to a nozzle, but that nozzle is connected to some other pipe. So this bad head reference direction is direction not same as terminal direction. So initially it was connected to nozzle, but nozzle orientation changed. So this can be reported. Similarly, there are a lot of categories over here. The head reference is not set, or head tube reference is not set. Catref in SQL. So this is a catalog problem. So some problem also appear because of wrong catalog or erroneous catalog. Not only all problems are because of modeling, right? H board not same as the HS tube. H connection not compatible with connection type of HS tube. Insulation spec reference points to a non-existing element. So insulation spec has been deleted. Something. Similarly, they are tail very similar to the head error. There are tail errors. Tube too short between head and tail. Bad head to tail geometry. Right. So they are not in line. H bore not same as T bore. When there if there are no components in the branch, the head bore and T bore must be same. Head connection is not compatible with tail connection. This branch has no components. So there are, so these are C. So okay. B are very similar to A. C are for branches with no piping components, right? Then there are component specific errors, which starts with D. For example, SPRE is not set, spec reference is not set, connection reference is not set. For example, multi-way components or even the T. Like if it is unconnected, it will say the end of the T is not connected. Right. So it's just a warning. Connection reference point to a if the T is connected to a branch which has been deleted, may reported bad connection return references arrive to less than minimum. Bad arrive leave geometry T410. So all the understanding of each error is and warning is explained here. This list is long. Then there are end component digest. So E category there are for only for end components. last component of the branch, right?